All right, let's go ahead and get started. So, good afternoon, everyone, and welcome to today's technical meeting on quantifying baseline emissions for California's building materials. My name is Lex Mitchell, and I'm the section manager in CARB's Embodied Carbon program. And I'd first off just like to say thank you all for joining us. This is the first technical meeting in a series we'll be holding this fall to support the development of the baseline and reporting framework for our Embodied Carbon program. The focus of today's meeting is the baseline emissions estimate and the technical foundations behind developing the baseline emissions estimate. The baseline emissions estimate is derived using a specific modeling approach, which will be covered in detail during this meeting. The outcome from this modeling approach is an estimate of the greenhouse gas emissions that are attributable to California's building sector. So let me say your input during these meetings is essential. These meetings are designed to bring together subject matter experts and to foster discussion. We value the input, feedback, and time that you all and members of the public can spend to help inform and improve CARB's initial proposals. So I'd like to cover a few logistics before we start. The meeting is being recorded and materials will be posted on the CARB website. Online participants may use the raise hand feature during the comment period. A public docket will also be available for submission of written feedback. Given the highly technical nature of the meeting, we strongly encourage written feedback to help us refine and improve our work. So in case of a fire, we're going to evacuate through the double doors in the back or this door on the side and meet across the street in Cesar Chavez. I don't anticipate that happening, but you never know. Cesar Chavez Park, I should have said. If you need to use the restroom and you're in person, you can go straight out this door all the way to the back and take a left under the chandelier and follow over that way. Or if you go to the right, there's double bathrooms on the right side as well. We'll begin today with staff presentations walking through the modeling approach, and afterwards we'll open the floor for in-person discussion and then invite comments from our online participants. So with that background out of the way, I'll hand it over to Jeremy Loeb, who will be guiding us through the meeting today.
Thank you, Lex. Good afternoon. I'm Jeremy Loeb, a air resources engineer with CARB's Embodied Carbon Program Analysis section. Today, we'll walk through staff's proposed approach for quantifying greenhouse gas emissions from California's building sector, what we're referring to as the emissions baseline. The baseline represents a reference point or a snapshot in time of current building sector emissions. This reference point is critical for identifying strategies necessary to achieve greenhouse gas emissions reductions that align with statutory requirements. In our March 2025 workshop, staff recommended using environmentally extended input-output or EEIO models to build this baseline. This meeting will provide an overview of EEIO models, why staff believe they're the best tool for estimating the greenhouse gas emissions baseline for the building sector, and the methods staff have used to adapt one EEIO tool for California. We'll start by grounding ourselves in what the baseline is, then explain how input-output analysis uses economic data to trace sector-level transactions. From there, we'll show how EEIO models overlay environmental data, like greenhouse gas emission inventories, to calculate sector-level life cycle emissions. Finally, we'll introduce EPA's open-source US EEIO model and walk through CARB's integration and use of this model to develop the baseline assessment tool. Our goal today is twofold: to establish a shared understanding of the baseline's role in the program, and to explain why staff recommend an EEIO approach to modeling the baseline. We'll cover several things. First, we'll provide some details relating to the mechanics of EEIO models, including how economic data sets are used for input-output analysis. Next, we'll review the structure of national models like US EEIO and state IO, and how input-output analysis can be expanded using environmental data sets. Finally, we'll spend some time discussing how CARB has utilized these models to develop a tool to estimate California-specific baselines for the building sector under different life cycle boundary considerations. We'll close by previewing the baseline assessment tool and inviting discussion and feedback on the proposed approach. So, what is the baseline, and how is it used? The baseline is a profile of the current greenhouse gas emissions associated with building materials in California's building sector. Establishing a baseline is critical for two program functions. First, the baseline provides a snapshot of where emissions are concentrated in the building sector. This will allow CARB staff to rank sectors and materials by impact and to focus reporting and reduction strategies where they matter most. Second, the baseline allows CARB to quantify how much emissions reductions could be required to meet the legislative mandate to achieve a 40% net reduction target by the end of 2035. The quantity of estimated reductions needed will then inform reduction strategies in future rulemaking sessions. Important, the baseline is a sector-wide emissions estimate. It is not an average or benchmark carbon intensity of specific building materials. Similarly, the 40% net reduction target does not mean that each building material will have a 40% CI reduction target. Material-specific benchmarks and material-specific reduction targets are a separate concept that will be discussed in the future. Before we dive into the technical aspects of baseline estimation, let's briefly revisit the program's previous public engagements. Our first workshop was held in September 2024. In this workshop, we introduced the concepts of building decarbonization and embodied carbon and outlined potential program structures. At this workshop, we received over 80 questions and comments on topics including EPD and LCA collection standards and methods, whether data must be specific to a facility or a product, which entities will be required to report, opportunities for standardizing and streamlining reporting, LCA accounting practices and system boundaries, the scope of covered building materials, and stakeholder education and outreach. Recordings and slide decks are available on CARB's website, and written comments were accepted after each workshop. In March 2025, our second workshop expanded on the program's scope and addressed questions raised at the first workshop. Staff introduced data standards for EPDs and LCAs, outlined manufacturer and project reporting requirements, and provided an initial recommendation to develop a baseline using a top-down EEIO approach. This workshop also received a robust set of public comments. Comments included support for the use of existing EPDs without additional data standards, concern over reporting revenue streams, and requests for clarification on whether specific materials would be subject to regulation. And staff plan to address these points at upcoming reporting workshops. There were also several comments relating to the proposed baseline approach using the US EEIO model. Staff plan to use today's technical meeting to address questions that were raised in prior comments. Staff has read and considered all comments that were submitted, and our consideration of those comments has helped to evolve our concepts. Next slide, please. So now, let's review how the baseline was introduced in previous workshops, beginning with California statutory requirements. Health and Safety Code, Section 38561.3, subsection B, specifies that the baseline is the estimate of greenhouse gas emissions for building materials. The developed point-in-time estimate will be used to inform the emissions reduction strategies needed to achieve a 40% overall net reduction in emissions. The statute provides two options: a industry average of EPDs reported in 2026, or the most relevant up-to-date data as determined by the state board. That second clause, the most relevant up-to-date data, is important. It gives CARB flexibility to utilize alternative data sources and information in lieu of EPDs to establish a baseline. The statutory language also uses some key terms that require definitions. These definitions should be familiar to many folks here, as similar definitions were presented in a prior workshop. These definitions have been updated to incorporate comments that were received since the last workshop. Staff is considering defining building material as a physical product or system that is used or produced by the building sector, and typically used in the construction of buildings and infrastructure. This definition includes all end uses, for example, all concrete used in California, regardless of project type. Similarly, staff is considering defining building sector such that it includes all economic activity related to product manufacturing and construction, renovation, maintenance, design, and siting of buildings and infrastructure. This reflects a comprehensive life cycle perspective. Finally, staff have proposed defining the baseline as an estimate of the total life cycle greenhouse gas emissions attributable to the consumption of building materials in 2026, using the most relevant up-to-date data. There are a variety of emissions accounting data sources that could be used to estimate the baseline. One emissions data source could be greenhouse gas emissions aggregated on a facility-specific basis. This sort of data is reported to governments annually and accounts for emissions from the total production of materials from each facility required to report. Another source of data is product-specific life cycle assessments, which provide detailed emissions estimates for each unique building material for which a detailed life cycle assessment has been completed. An emissions accounting approach that relies on product-specific LCAs could make use of EPDs and EPD reporting. However, reliance on EPDs poses several major challenges. First, EPD availability and data quality is uneven, leading to comparability and consistency issues. Not only do many unique building materials lack EPDs, but they are also not held to universal, detailed standards for data transparency, verification, environmental attribute accounting, system boundaries, data vintages, or emission factor data sets. Second, even if there were EPD data that could cover all building materials used in California, additional data and methods would be necessary to estimate the building material usage quantities in order to calculate the total emissions associated with each product. Because statewide material usage is not yet being tracked in ways that correspond to the EPD level of specificity, or the same functional units reported for each EPD, this estimation methodology would rely on additional assumptions. Facilitating the use of EPDs with existing data would introduce additional error, uncertainty, and complexity into the baseline estimate. Because of these limitations, staff flagged significant concerns with relying on EPDs to develop a baseline to estimate the 2026 emissions that may be attributable to building materials. After weighing the options, staff proposed using an emissions data source corresponding to facility-specific rather than product-specific data. This has led to selection of an EEIO model, specifically US EEIO, the starting point for estimating baseline greenhouse gas emissions. The pros and cons of this approach, shown in the table, were discussed at the March workshop. As shown in this table, the main benefits of the US EEIO modeling approach are that the model provides a complete picture of building sector emissions with minimal emissions or double counting. This concern would exist for most bottom-up modeling approaches using EPDs or other LCAs. One drawback of the US EEIO approach is that its data sets are updated fully on 5-year intervals, and the EPA has signaled that it will no longer maintain US EEIO. However, development and updates to US EEIO are expected to continue through a consortium led by Stanford University and private partners. Data vintage concerns are not unique to US EEIO data sources, but also extend to EPDs, which may have primary data that is more than 5 years old, as well as significantly older background data. So, what does this EEIO approach to estimating baseline emissions look like in practice? Conceptually, the total economic demand for California building materials is multiplied by their sector-specific greenhouse gas emissions intensity. The greenhouse gas emissions intensity is derived by aggregating facility-specific data. These data come from facility-specific measurements that are reported to governments and attributed to specific industrial sectors. Each sector's aggregate greenhouse gas emissions are mapped to the overall economic output from that sector. Government-issued data sources are used to do this mapping. The result is a statewide estimate of emissions that are attributable to building material usage in the state. A key analysis choice is deciding which life cycle stages to include. Staff propose covering A1 through B5, which includes raw material extraction, manufacturing, transport, installation, and ongoing maintenance and replacement for buildings and structures. Stages beyond B5, like operational energy and end-of-life disposal, are excluded, as they are likely to add significant additional modeling complexity and to account for a small increase in additional emissions with little opportunity for the building sector to control or reduce. I will now hand this presentation over to my colleague, Jeff Kessler, who will discuss input-output modeling in more detail.
Good afternoon, everyone. I'm Jeff Kessler, the staff air pollution specialist in the Embodied Carbon Programs Analysis section. The first part of today's meeting reviewed the key considerations for developing a baseline estimate for building material emissions. All material from today's tech has been posted online. Some of the material presented today has been repeated from prior workshops. We encourage all of you to familiarize yourself with the 2 prior public engagements if you have not already. Recordings from these past workshops are also available online if you'd like to revisit them. I'm now going to cover some material to further set the stage for how CARB staff intend to use the baseline and the methodological underpinnings for the emissions assessment work we are doing to establish the baseline. First, it is important to understand the context for how the baseline will be used and how it relates to the data we plan to start collecting from entities that will be required to report to our program. The baseline serves 2 important roles for the Embodied Carbon Program. First, it helps to reveal the products or industries with the highest emissions, where emissions are concentrated in the building sector. This helps CARB staff identify key reporting and submittal requirements that will ensure that the highest emission subsectors and materials are being reported to CARB. Relevant and accurate reporting is essential for CARB to track progress toward any future emissions reduction targets that may be established. Second, the baseline modeling approach being developed by staff provides sector-specific emissions intensities that are relevant to specific building material industries. Due to this level of disaggregation, the baseline and baseline methodology will be used to help identify how different policies, programs, and future regulations can be used to achieve an overall 40% net reduction in greenhouse gas emissions for the building sector. Establishing a baseline is the first step towards developing future compliance strategies and any additional emissions reduction regulations that may be necessary to achieve the statutory goals. In other words, the baseline helps guide reporting priorities for this rulemaking cycle and will also inform future emissions reduction strategies. The baseline tells us where the largest emissions are and how far we need to travel to meet the 40% reduction target. Staff compared several existing life cycle assessment tools to better understand which life cycle emission inventories and tools may be most relevant for our task of establishing a baseline. When evaluating these tools for suitability, we assessed each tool based on its geographic relevance, or how specific it is to California, data ownership and accessibility, or the transparency associated with the data, sector specificity and relevance to the building sector, life cycle stage coverage and the stages and scopes that are covered, and licensing and cost considerations affiliated with tool use. Many tools listed on this slide could be used to help support product-level LCAs. However, to develop a comprehensive emissions inventory relevant to California's building sector, additional modeling and data sources are necessary. For instance, there is not a bottom-up data source that presently exists which quantifies all building materials that are used for each project completed in the state of California. As such, modeling is necessary to quantify the use of building materials in the state. Staff determined that the US EEIO model provided the most comprehensive set of data and methods to be well suited to estimate baseline emissions. The economy, and perhaps the slide, is strikingly complex. To estimate the life cycle emissions associated with building materials, it is necessary to understand how different energy and material flows across the economy and is used to ultimately create a building or structure. Input-output analysis is a powerful approach that has been developed to understand and to quantify the interconnectedness of the economy and the various sectors. Building a house, for example, involves not only procuring lumber and concrete, it also involves the production of cement from the mineral products manufacturing sector, aggregates associated with mining, and electricity procured from electric utilities. Each of these upstream activities has its own procurement pathways associated with their upstream emissions. Input-output analysis is a mathematical approach that is used to map the overall relationships for interconnected industries. When input-output analysis is incorporated into a life cycle assessment framework, it can help us better quantify both the direct and indirect emissions associated with building materials used to construct buildings and structures. With that context, let's look more closely at how input-output analysis works and why it provides such a strong foundation for estimating an emissions baseline. An input-output model captures the ripple effects of an economy. That is, the output from one sector is contingent on a very complicated set of producers providing different goods and services that will all need to change their own levels of production to satisfy an increase in demand from a different sector. Think of it as a network of transactions. Sectors buy input from each other, transform them, and sell outputs to consumers and other customers. These transactions are called inter-sector flows. For example, natural gas sold to the cement manufacturers is one such flow. Not everything produced in the economy ends up being consumed as final demand. In fact, most economic outputs end up being consumed by other businesses as intermediate goods to create additional goods or services. Final demand refers to something very specific and only covers the set of goods and services that are not used as intermediates. Final demand is primarily carried out through consumption by private households and government purchases. To keep these flows organized, IO models rely on classification systems like the North American Industrial Classification System, or NAICS. This standardizes how industries are defined and classified across the economy. NAICS codes classify businesses by the work that they do. The first two digits represent broad sectors, and each additional digit adds specificity down to industrial industries. Government uses NAICS to collect economic data, and businesses use it to benchmark markets and qualify for different contracts. The system is updated every 5 years to stay relevant to new industries. NAICS is a key system used for aligning emissions data with the right economic sectors in the environmentally extended input-output model, which we will be discussing in more detail in just a little bit. The IO model framework was developed by a Nobel Prize-winning economist, Wesley Leontief, who developed the first systematic method to trace the interdependencies of a complex global economy. Input-output analysis is all about connecting the dots between industries and quantifying the flows of goods and services across the economy. For example, producing a car isn't just about the auto sector. It involves steel, energy, transportation, and electronics, which are all industries that are reliant on other industries in the economy to function. IO models capture both direct and indirect inputs, giving us a full picture of the resources that the economy must provide for a given sector or industry to continue to produce goods and services. Today, CARB and other government agencies rely on input-output models for economic forecasting. This includes things like estimating the number of jobs that may be created or destroyed by a given program or policy. CARB uses tools like REMI, an input-output modeling tool, to meet the requirements of the Administrative Procedure Act to quantify the economic impact to the state and its businesses that a given policy might have. CARB has also made use of the IMPLAN model, another input-output tool, to evaluate and estimate health and other impacts that different scoping plan scenarios may have. The IO modeling methods use linear algebra to mathematically quantify the economic flows between sectors and to determine the overall input needed for the economy as a whole to meet the production needs from a given sector. The economic data used for input-output modeling starts as a large table and is transformed into matrices that describe how much direct input each sector needs to produce 1 unit of output. Total output tables show the gross value of production from each sector, or the total economic output that a sector has produced in a given year. This includes both intermediate goods sold to other sectors as well as final goods sold to consumers, governments, or for export. Intersector flow tables map the transactions between sectors. For example, they quantify how much the construction industry purchases from cement, steel, or insulation manufacturers. This direct input is quantified based on economic data associated with purchases made by companies that make up the sector. These data are collected by the federal government. Final demand tables isolate end-use consumption. These tables track how goods and services are consumed by households, government, and exports, separating final demand from intermediate use by other industries. The direct requirements table, also known as a technical coefficients table, standardizes input needed per single unit of output. It shows for each sector how much direct input is required or purchased from every other sector to produce 1 unit of output. This table is essential for the linear algebra that quantifies both direct and indirect economic and environmental effects. The next several slides will break this down in more detail. The total output table provides a snapshot of how much value, typically in dollars, each industry or sector contributes to the economy. It includes both goods and services sold to other sectors, like raw material to manufacturers and those sold directly to consumers. As can be seen on this slide, the total output table details the total output or economic production from all sectors of the economy. The total output table is often the starting point for modeling economic flows and understanding the ripple effects or changes in production or demand. The direct requirements table shows the direct inputs needed from other sectors that are necessary to make $1 of output for a given sector. It is easiest to think of this as the line item purchases that a business ultimately needs to operate on a day-to-day basis. For instance, construction entities making commercial structures will need to procure lumber and other goods. There are numerous other direct inputs that will be necessary for a construction entity to produce their economic output, typically a structure or building. Similarly, a lumber manufacturer may also require dimensional lumber to maintain structures that are fundamental for use to conduct its business, among many other outputs from other industries. The direct requirements table normalizes the total demand for inputs by the total economic output for each industry. That is, the total receipts or direct inputs to a sector is divided by the total economic output from the sector. Finally, the final demand table shows the total amount of output that is used by final customers, rather than by businesses that use the output to support the creation of further economically valuable goods and services. For example, certain types of wood products may be purchased by private households, where it counts as final demand, but it may also be purchased by construction firms, where it counts as an intermediate product that goes towards creating a building or other structure. All the tables we have walked through are used to understand how the economy is interconnected and tied together. The next several slides will provide a brief overview of the linear algebra that is essential for estimating the total interconnected economic flows, which in turn enables life cycle emissions to be estimated. This slide shows the basic balance equation that underpins the fundamentals of input-output modeling. I know that equations like this can be a little intimidating. I will go over each term in the equation, and I hope that this will help make this material accessible for any participants that are seeing this sort of modeling for the first time today. The first term in the equation, x, is the total output from the economy. Because it's a vector, that means it contains the total output from each sector in the economy. However, it may be simplest to think of it as the output from a single sector, which may help improve your own intuition for what the equation indicates. This equation states that the total output from each sector in the economy must be equal to the two other terms on the right-hand side of the equation. The term AX on the right-hand side of the equation uses the direct requirements matrix, A, if you remember from a few slides ago. The direct requirements matrix indicates the quantity of goods and services a given sector directly purchases from all other sectors in the economy in order to produce 1 unit of output. In other words, the AX term specifies the quantity of material or output that each sector in the economy directly needs to purchase from all other sectors to satisfy the amount of output that they produce. Finally, there is the Y term, or final demand. Final demand is the amount of output that is used to satisfy final consumption. As a reminder, this is consumption of goods and services that are not fundamentally used by other businesses in the economy to create additional goods and services. When taken all together, this equation states that the total output from each industry in the economy must be equal to the total demand for intermediate goods, as well as the total demand for goods that are sold directly to final consumers, such as private households and the government. As may be evident from this equation, the amount of output a given sector needs to create is dependent on the amount of output that other sectors also need to create to satisfy the total economic demand for all goods and services within the economy. Next, we'll go over some linear algebra that is done to simplify this equation. The first step is to rearrange the equation to solve for x, that is, the total output from the economy. Because this is done using matrices, we end up with the inverse of the identity matrix less the direct requirements matrix. This inverted term is then multiplied by the final demand vector, y. To simplify this expression, the I minus a term is defined as a Leontief matrix, or L matrix. The character L is directly substituted into equation 2, which results in what we have written for equation 3. Now that the math is out of the way, let's consider what the L matrix represents. The L matrix is the most important component of input-output analysis, as it represents the total requirements from the economy, both direct and indirect, or upstream economic requirements that are necessary to meet a unit of final economic demand. Because of the equation rearrangement, this matrix carries the full life cycle mapping from all the economic productivity from the economy to meet final demand. In other words, because the total output from an economy, X, is a function of the intermediate demand for that output, as well as the final demand for that output, the L matrix establishes the relationship for how output across the entire economy must change to ensure that the final demand for goods and services is met, when considering the interconnectedness of inputs across all sectors of the economy. As a reminder, these slides are available on the Embodied Carbon website, along with other resources. Now that we have gone over the basics for establishing the equations that relate total direct and indirect economic requirements in the economy, we are going to present several slides that provide the mathematical relationships for how this input-output model may be expanded to estimate total life cycle emissions affiliated with the economic output from relevant sectors. I will now pass the presentation over to my coworker, Leo Guillot.
Good afternoon, everyone. I'm Leo Guillot, an air resources engineer in the Embodied Carbon Program Analysis section. Over the next several slides, we'll move from input-output basics into environmentally extended input-output models, or EEIO. EEIO is how we connect environmental flows, like greenhouse gas emissions, to the economic transactions and relationships we just discussed. This is what allows us to establish a credible, California-specific baseline estimate. EEIO models expand input-output models by layering in emissions and waste streams. These include air pollutants from factories and power plants, water pollutants from industries and in agriculture, solid waste from extraction and manufacturing, and greenhouse gas like carbon dioxide, methane, and nitrous oxide. These data come from federal and state inventories, which we link to the input-output structure so emissions can be traced back through supply chains. In input-output terms, the Leontief matrix L tells us all the input direct and indirect that are needed to meet 1 unit of final demand. When we map emissions data onto those flows, we can assign emissions to every dollar moving through the supply chain. That way, we capture not only direct smokestack emission, but also the hidden upstream impacts that are embedded in materials. Here is a concrete example. In the 2017 US EIO model, for every $1 of ready-mix concrete, represented by the NAICS 327320, there is a direct requirement for cement, electricity, and limestone. However, most sectors in the economy must also produce some amount of goods and services in order to satisfy the direct input that the ready-mix concrete plant requires. For instance, 16 cents of cement is needed, both directly and indirectly, to produce $1 of concrete. Cement manufacturing contributes emissions primarily due to calcination of limestone and combustion of fuel. 3 cents of electricity is also needed across the supply chain. Electricity use contributes emission based on the grid mix that is utilized to satisfy the electricity demand needed to produce concrete, both directly at the ready-mix plant and indirectly to produce all the inputs that are used in the ready-mix plant. Lastly, 3 cents of limestone mining and 0.6 cents of natural gas are also required across the economy. Production of these resources similarly have their own direct and indirect emissions affiliated with extraction and transport that occur outside of the ready-mix concrete facility. Because the Leontief matrix quantifies both direct and indirect economic requirements, totaling these contributions and the associated emissions for producing each of these requirements gives us a life cycle emission factor for concrete expressed in kilograms of CO2 equivalent per dollar of final demand. EEIO rests on 2 building blocks. First, environmental satellite tables, which quantify emissions and waste that are associated with total production from each sector, and life cycle impact assessment factor tables, which convert gases, such as kilograms of nitrous oxide, into carbon dioxide equivalents using global warming potentials. Combining these tables produces direct emission factors for every sector. We will now go into this more in detail over the next several slides. Environmental satellite tables measure the annual quantities of emissions for greenhouse gases, as well as other air pollutants and wastes at the sector level. Staff rely on programs such as the EPA Greenhouse Gas Inventory and CARB's mandatory greenhouse gas reporting regulation to populate these tables. On the right here is an example for NAICS 236, representing the construction of buildings. It lists species and annual emissions in kilograms like carbon dioxide, several HFCs, methane, and nitrous oxide. Only species with emissions reported for this specific sector are shown on this slide. Other inventoried species may not have sector-specific flows or may fall below reporting thresholds. To put different gases on the same scale for measuring environmental impacts like climate change, EEIO applies life cycle impact assessment factors. The 100-year global warming potentials from IPCC and EPA Tracy can be used to convert methane, nitrous oxide, HFCs, and other chemical species into CO2 equivalents. Using a consistent set of indicators allows for comparisons of totals across sectors and over time, and changes to the set of global warming potential values, like switching from older IPCC values to more recent ones, such as those in AR6, can be transparent to stakeholders. EEIO rewrites the input-output identity we saw to solve directly for environmental impacts. It uses the relationship X equals L times Y, which represents the total output needed to satisfy final demand. And it attaches emissions with the equation E equals C times B times X. Here, the C matrix represents the life cycle impact assessment factor, which is a matrix of global warming potentials, converting the mass of each gas to carbon dioxide equivalents. B represents satellite data, which is a matrix that quantifies direct emissions from each sector per dollar of sector output. For instance, kilograms of methane per dollar of product produced. With B in kilograms of gas per dollar and C in kilograms of CO2 equivalent per kilograms of gas, the resulting emission matrix E is in kilograms of CO2 equivalent per dollar of economic output. EEIO simplifies the impact equation we saw by combining characterization and emissions into one term. It defines D equals C times B, collating the LCIA factor and satellite emissions coefficient into a single matrix of direct, Scope 1, impact intensities per unit of sector output. The L matrix we discussed about, and you can see in equation 5, propagate those intensities through the supply chain. And multiplying it by Y attributes total life cycle impacts to final demand for products. In EEIO, the direct impact matrix D is built by combining characterization factors with multiple favorable satellite datasets, so we have direct impact intensities per unit of sector output. The table on this slide shows the main sources we use and what they contribute. The US EPA provides the National Emissions Inventory for air pollutants, the Toxic Release Inventory for reported releases, the Greenhouse Gas Inventory for GHGs, the Discharge Monitoring Report for water discharges, and the Advancing Sustainable Material Management Sheet for solid wastes. The US Energy Information Administration provides the Manufacturing Energy Consumption Survey and the Commercial Building Energy Consumption Survey, which is for energy use by fuel and sector. The US Department of Agriculture provides the Agricultural Chemical Use Survey for fertilizers and pesticide applications. The US Geological Survey provides a Minerals Commodity Survey for the extraction and processing context for key materials. All of these inputs, together with EPA Tracy and other LCIA factors, form D in consistent units, which are then propagated in the model through the supply chain with the Leontief matrix L. We can simplify the calculation by pre-computing a new matrix. We call this matrix N equals D times L. So the total impact becomes E equals N times Y. Interpreting this, N contains the life cycle emissions intensity for each sector, direct plus all upstream effects expressed per unit of final demand. For instance, there is a considerable final demand for new construction in the state. Multiplying the final demand for new construction by the N matrix can provide the total life cycle emission estimates for new construction. In other words, N can be multiplied by California's final demand for output from various sectors to produce emission estimates, with units in kilograms of CO2 equivalents. This slide shows N as a table. It contains a sector name, a BEA code, a region suffix, here USCA standing for California production, and the life cycle intensity in kilograms of CO2 equivalent per dollar of final demand. EEIO works by combining satellite tables and characterization factors. As we've seen, together, these produce sector-level impact factors, such as kilograms of carbon dioxide equivalents. By combining these factors with the direct impact and Leontief inverse matrices, we can propagate these emissions through the supply chains and assign emissions to final demand, identifying different areas in the economy that contribute the most to life cycle emissions for other sectors. The N matrix is a computed version of the emission impacts that bundles all the direct and indirect emissions into a single table of carbon intensities, which can be applied to California consumption data. In this section, we'll introduce the modeling backbone for estimating the baseline. Staff will walk through the national US EEIO model and general details about the state IO model, and then how they work together to produce California-specific life cycle emissions estimates. The goal is transparency and reproducibility, so that anyone can follow the steps that lead to generating a baseline emissions estimates for California's building sector. US EEIO is a nationally representative EEIO model of the US economy. It calculates both direct and indirect environmental impacts. It was developed by the EPA and can be used to support life cycle assessment, policy analysis, and sustainable materials management. Staff can adjust the model by base year for the data used, sectoral detail, about 70 summary sectors or 400 detailed sectors, and environmental datasets. For implementation, staff relies on EPA's open source tools, FLOSA, Input-Output Model Builder, LCIA Formatter, and the US EEIOR package. The approach links economic structure to environmental data using consistent codes and tables. The L matrix that we've seen is derived from BEA input-output accounts and gross output by industry tables. It gives total economic requirements to produce $1 of output from each sector. The D matrix is assembled from federal and state environmental datasets and characterized with LCIA factors to represent direct impact intensities per dollar of output from each sector. The life cycle emissions are mapped by BEA codes with BEA to NAICS crosswalks so each sector's direct and upstream impacts can be estimated. The US EEIO model makes use of specific government datasets to conduct the input-output analysis. The BEA make and use tables are the foundation for this input-output analysis. The make table, V, shows which industries produce which commodities, providing an estimate for the total economic output from each sector. The use table, U, shows which industries and consumers purchase those commodities, providing an estimate for the total economic demand for outputs from each sector. V and U together form the direct requirements matrix, the A matrix, which feeds into the Leontief inverse matrix, which details the total economic requirements to produce $1 of output from each sector. One caveat is that BEA data has a lag. Sector and summary data is updated annually. The most current release is for economic transactions from 2023, with an update that is expected to be released soon for 2024. Detailed data is released every 5 years, and the current cover is for the year 2017, detailed economic transactions, which was released in 2024. State IO is used to adapt the US EEI model we've just seen to a specific state. It is used to generate a two-region input-output model, the state of interest, and the rest of the US. This separation allows us to distinguish in-state production from domestic production that is imported into the state. The two-region model is built from national input-output tables and state industry trade data. This is then combined into a usable EEIO structure with FLOSA, the EPA tool that maps emission inventories to specific economic sectors and industries. The two-region model has a resolution initially at the BEA summary level, which is roughly 70 commodities per region, rather than the approximately 400 in the detailed one-region model. Staff use the state IOR package to create a two-region input-output model that is specific for California. This is our starting point before applying CARB customizations. US EEIO also incorporates international imports. Imports do not use the US emission factors. Instead, staff rely on a multi-region input-output model to parameterize the import emission factors. Currently, staff have parameterized import emission factor using XEO-based data, aligning with the work that US EPA has previously done to integrate import emissions into the US EIO model. Commodities are linked to their country of origin and paired with country-specific emission intensities. This improves accuracy for consumption-based accounting. Now, let's look at how staff customized these frameworks specifically for California. Two major modifications were made to ensure that this baseline modeling approach will better reflect California's data and sectoral detail. This diagram shows how the pieces connect. We start with data. So the blue boxes on this sheet here are specific data sources, while the teal box are specific models that CARB is using. The yellow boxes are the things that CARB staff has spent time incorporating into the existing data and models to ensure that the tools better reflect California. As you can see on the left here, CARB's 2022 GHG inventory is our anchor for California greenhouse gas emissions and replaces default state values that have been generated by the US EPA for all states, including California, based on their national emissions inventory work. EPA's National Greenhouse Gas Emissions Inventory fills gaps and provides a cross-check. BEA's Make and Use table supplies the economic backbone for how commodities and services are transacted across the economy. XCO base is a different multi-region input-output model that we have used to give us greenhouse gas emissions intensities for imported goods so that they are not treated identically to goods produced domestically in the US. State data from Energy Information Administration, the US Census, and Bureau of Transportation Statistics refine the California picture, providing energy use, industry mix, and freight flows for goods and services. All these inputs feed the EPA models. FLOSA maps the inventories to BEA and NAICS sectors and produces a California environmental satellite table which details the greenhouse gas emissions that are associated with specific industries. State IO builds a two-region input-output economic model, California and the rest of the US, from BEA economic data supplemented with specific trade statistics. US EIO then combines the economic structure with the satellite tables and import adjustments to calculate direct emissions and life cycle emissions intensities. CARB's matrix decomposition, in yellow here, takes the California summary results and redistributes them to 400 plus detailed sectors using national detailed shares, preserving California emissions and economic totals while adding additional detail that is incorporated into the baseline assessment tool. So, there are two targeted changes. The first modification is the integration of CARB's GHG inventory. Staff replaced EPA's default state emissions inventories for California with CARB's officially released inventory, which covers greenhouse gas emissions through 2022. This is the most recent public release of the California greenhouse gas emission inventory. The emissions inventory data for each activity have been mapped directly to Bureau of Economic Analysis codes, which uses the NAICS system to ensure that emissions can be attributed to specific California industries. The second significant modification CARB staff made is a matrix decomposition to provide increased resolution for emissions that may be attributable to specific sector. Staff disaggregated State IO's 70 summary sectors into 400 plus detailed sectors. This adds precision for building materials while preserving overall California emission totals that are affiliated with more aggregate sector. As shown in this table, each emission flow in CARB's inventory is mapped to a specific BEA sector to build a California-specific satellite table by industry. You can see an example here. This table is incorporated in FLOSA and written out as a CARB satellite file that replaces the default California greenhouse gas emissions inventory that was previously generated by the US EPA, which is otherwise used in the two-region US EEIO model. The US EEIO-R configuration incorporates this California-specific file to compute a California direct emissions matrix using the relationship D equals C times B, where C is the GWP characterization and B is the CARB satellite data in kilograms of gas per dollar of economic output. The result is a direct impact value that shows the greenhouse gas emission impact per unit of economic output in California. The second modification is to change the level of disaggregation presented in the direct requirements matrix. To compute the total economic need for inputs, the direct requirements matrix is multiplied by the total demand for output from that sector, which gives the input matrix presented in the equations here. The idea is to keep demand for California's sector at an aggregated level constant, but to redistribute overall demand for sector inputs across detailed subsectors consistent with the economic requirements for the US as a whole. Doing this assumes that industries producing output in California require a similar percent breakdown of detailed inputs from the economy as would be required for that industry on average in the US. Staff first takes the National Detailed Input Matrix for 2017 and compute for each detailed pair ij the share of input within its parent summary sector. This gives an overall breakdown for how economic activity within a given sector corresponds to its aggregate summary sector. Those shares become scaling factors, as you can see on the second equation here. Staff then applies the factors to the California summary inputs matrix so that the input state variable for detailed sectors preserves the California total while reflecting national detail for how those input needs can be split across more detailed subsectors. Staff repeats the same approach for emissions. Using a national detailed results, staff compute detailed emission shares within each parent summary sector. And then scale California summary emissions to detailed sectors with those shares. From the detailed input and emissions, staff derive California's detailed model matrices. The detailed direct requirement matrix, denoted here as A state, the Leontief inverse matrix, L state, using the relationship L equals to the inverse of the identity matrix minus A state, and finally, the D state matrix, giving detailed direct emissions factors per unit of output. All of this yields the full output for California at a detailed resolution, 402 sectors instead of 71, ready to be used for baseline estimations. Staff have built an Excel front-end, the baseline assessment tool, that presents the results from our California-specific EEIO model at the detailed sector resolution. It loads California's detailed A, L, and D matrices in it, so users can see and work with them directly. Results from the customized California EEIO model are incorporated into the workbook, returning applicable emissions estimate. The estimates in the workbook have also been scaled so that they represent detailed emissions estimate for the baseline for 2026. In practice, one can select the relevant construction final demand categories and different years to project out demand for those sectors, review the underlying emission factors, and produce baseline emissions for a subset of years in a transparent, auditable format. The tool is intentionally simple. It displays the calculated intensities, multiplies them by the chosen California demand, and report lifecycle CO2 equivalent values consistent with the modeling. In the current version of the tool, staff propose to estimate the baseline using lifecycle stages tied to materials of manufacturing, their installation, and maintenance. The scope covers A1 to A3, representing raw materials, transport, and manufacturing of building products, A4 to A5, representing transport to site and installation, B1 to B5, representing use, maintenance, repair, replacement, and refurbishment over the useful material lifetime, A1 to A5 stages are captured primarily by the construction sector, denoted by NAICS code 23, while B1 to B5 stages are captured through other sectors in the EEIO model. The results show baseline emissions focused on manufacturing, installation, maintenance, and repair impacts, excluding operational energy and end-of-life stages. Staff propose that the building sector capture the final consumer demand for construction industry products, representing what the construction industry delivers as a finished output. That includes entire building types and major structure categories like healthcare and school buildings, residential and non-residential repair and maintenance, commercial and other non-residential structure, multifamily and single-family homes, utilities buildings and infrastructure, highways, streets, bridges, and manufacturing buildings. Staff also include a small set of additional products that households buy directly, so we can represent in new stages B1 to B5 more completely. This table lists the specific BEA codes and products: lumber and plywood, windows and doors, veneer and engineered woods, clay, ceramic and glass products, cut stones, miscellaneous fabricated metal products, construction machinery, and selected HVAC equipments. We also include housing services, owner and tenant occupied, and architectural engineering services, where they help represent B-stage activities. I will now pass this off to my coworker, Jeff Kessler, to discuss the baseline assessment tool that staff have created.
Thanks for that, Leo. I think maybe for those in the room as well, you might just want to stand up for a second, and then we can sit back down. It might create some revitalization. So I'll give you just a couple seconds to stand up and stretch a little bit before we dive into this last section. Those online might also like to do that. Great. Thanks all so much. So at this point, we've reviewed the structure and approach for how staff intend to estimate the baseline and the modifications made to the underlying models to ensure that the baseline estimate reflects the best available data for California. Next, we're going to walk through the baseline assessment tool that staff created. This is an Excel-based workbook, so hopefully it's accessible to everyone, and it compiles the results of the CARB-modified USEO model and applies some additional scaling and aggregation considerations to estimate the baseline emissions for the 2026 year. When you open the tool, the first sheet that you're going to see is the About page. And so that's currently being shown on the screen. This provides an overview of the tool as well as a color legend that differentiates worksheets and cells by their function. Next slide. Yep. This is the sector selection worksheet. And so this worksheet provides the option for users of the tool to define which final demand sectors should be included in the overall building sector definitions for the baseline estimate. As a reminder, we've discussed final demand and what that actually means in a bunch of slides. So definitely go back and refer to those. Final demand here refers to household consumption. So that's, for instance, the sales to individuals, investment, so spending by businesses on fixed assets, government consumption, international exports, and changes in private inventory. So excess stock that is not directly used to purchase or to produce additional output. So this is different from consumption of products or commodity that are used to produce a final product, like a building or a car. The material consumption for inputs used to produce buildings or cars would not be reflected in the final consumption total. But instead, those would be reflected in the value of output from the building sector or automotive industries or automotive sector, respectively. So most products are consumed by industries as intermediate products. So for instance, for this tool, most building sector related steel is consumed by the construction industry and very little is purchased by end users. Outputs from the construction industry, so for instance, single-family homes, those are purchased by end users, so individuals, and the demand for input of materials, services, and energy to create those structures is included in the life cycle emissions estimates for outputs from the sector. Slide 58 has the dashboard results from the tool. And so the dashboard result worksheet shows the total baseline emissions based on the sectors that the user selects for inclusion as part of the building sector. This worksheet also allows the users to select from several different years to define the final demand projections that are used to calculate the baseline. So you can scale it between, I think, 2022 and 2027. These projections are done using economic forecasts that come from the REMI model, and that's the tool that CARB uses to estimate economic impacts for our regulations and other programs out to the future. This is the attributable baseline emissions slide. And so this worksheet shows the total greenhouse gas emissions attributed to each sector that was selected in the sector selection worksheet. Data are expressed in various terms, including kilograms and million metric tons of carbon dioxide equivalents, their overall contribution to percent emissions in the building sector, and the total economic activity. The total life cycle emissions is affiliated with final consumption of output from the sector. So the value of healthcare buildings constructed by the construction sector in a given year is one example. The total demand for commodity from each sector is multiplied by the total life cycle requirements to produce that commodity output from each sector. This reflects the complete production across the economy that is necessary to meet the total building sector requirements in California. So as an example, building all of the structures in the state in a given year. Because this represents the total requirements, it aggregates quantities for both the direct inputs into the building sector, as well as all those indirect or life cycle inputs needed by the building sector, such as the coal and natural gas purchased by material manufacturers to produce products that are then purchased by the construction firms. I will now pass this over to Jeremy Loeb to lead us into the public discussion session.
Thank you, Jeff. Just a few more slides before we get that started. We are now going to spend an hour, or plus or minus, on public discussion. We invite the experts in the room to ask questions and to provide recommendations based on the technical details of the work that was presented today before we open the floor to a public comment period. Staff will serve as moderators for the discussion and can respond to questions to clarify work we have done as needed. Online, we have a few attendees that have been marked as panelists so that they may better participate in the public discussion. This includes Wes Ingerson and his colleagues that have been instrumental in developing and creating EPA's US EEIO model. So if you would like to add to the conversation, please raise your hand. There are microphones placed around the room, which are important for making your voice heard in the room and for online attendees. So please do speak clearly into the microphone. If your question is not related to the technical details of modeling and is better suited for the public comment period, you will be given the opportunity to comment during the public comment period. For online attendees, you will have the option to participate during a public comment period at the end of the meeting. We will also be opening a public docket on the CARB website to facilitate written comment submittals. After today's meeting, CARB will also post a template on the Embodied Carbon website that can be used to help provide specific technical feedback that directly relates to the disaggregation percents that CARB has used to estimate detailed emissions. Next slide, please. There we go. Before we begin public discussion, we'd like to propose some conversation starters and questions we are looking to receive written comments on as well. First, are there significant emissions associated with the building sector that current staff approach does not adequately capture? Are there methods or approaches staff should consider for changing how A1 to B5 emissions are estimated using US EEIO data? Should the scope be revised to better account for US EEIO limitations? What additional tools or information would interested parties like to have access to in relation to the baseline? Additionally, have staff excluded any sectors where final demand for example, commodities sold directly to end consumers, such as private households, should be included as part of the building sector. Conversely, have staff included any sectors where final demand should not be included as part of the building sector? Staff have relied on national weighting factors to disaggregate the course 71 sector-specific outputs to 400 plus California-specific sectors. Are there different weightings or weighting approaches you'd recommend that might improve the results? If you have specific comments related to weighting approaches, we encourage you to make use of the weightings template we will post to the Embodied Carbon website at the conclusion of this meeting. And with that, I think we can shift gears here.
Okay. All right. Hi, everybody. Thanks so much for the time today. I know that was relatively dry technical content that we wanted to set the stage with, but hopefully we can have a good discussion now. As we mentioned, there's microphones on the table. If it's red, it's off. If it's green, it's on. Press the button if you'd like to make a comment. Just before we dive in, though, just to remember that we are limited on time to some extent, so I appreciate if you can be concise with your comments and be respectful of obviously everyone else's time. We want to hear from as many people as possible. And obviously we want to talk today about the baseline. And we know we have a lot of questions and concerns about other issues that are related to the development of this regulation. But today we're here to talk about the development of our baseline estimation methodology. So we're hoping to have comments, stay focused on that. And obviously constructive criticism is very welcome. We're very excited to hear from your opinions in any way, but we want to ensure that our feedback is always respectful and obviously fostering improvement in the overall product. So if we get a little off topic, I might jump in and say, as I said, microphone's on the table. Anyone want to kick us off?
Had the benefit of some practice in this room yesterday. So, hi, Mary Solecki with AJW. I just wanted to clarify something that I'm sorry I missed a good chunk of the preceding portion. So maybe you all went out over it in more detail, but in just presentation, the discussion of steel and there being an intermediary purchaser, and so that maybe not being considered in the same way. I was wondering if you could just go over that again, please. I wasn't sure if I had question. I just needed a little bit more clarification there.
Yeah, thanks for that question. I'm sure other people also share it. So when things are getting categorized in the modeling context, you either have purchases that are intermediate purchases, so businesses are primarily buying it to then create an economic output. So steel, for instance, there's basically no end use, like private household consumption of steel I-beams, so that from an economic perspective, I think in the model, I need to double check, 100% of like the steel I-beam purchases are from other businesses. So you'd have the construction industry purchasing the steel I-beams, not private households. So in the baseline modeling tool, when you have home building as one of the construction sectors, the steel consumption is reflected from their life cycle assessment, not from the steel being sold to a private household. If that cleared it up or maybe added more confusion.
No, I think that makes sense. And maybe that's more obvious when you start looking into the tool that you've built. But so does that mean that other materials like concrete are in the same bucket and wood products?
Yeah, so there are some wood products that are purchased by private households that do show up. And then there's a lot of other wood products that are primarily purchased by basically the construction industry. So when you include in the selection tool emissions, basically it's the final demand. So it's the final product of construction that end users are buying. So those are houses and hospitals and the buildings that are being constructed. And there is some final demand that is also potentially includable in the building sector definition.
Thanks, Jeff.
I have a more fundamental question. Steve Myroney with the Spray Foam Coalition. I'm sure many different manufacturing groups have mentioned that their individual contributions to the emissions of the construction industry are minimal. Obviously, when you add them all up, there's a total number, and that's what CARB's trying to estimate here. How does data from a spray foam manufacturer make it into this model? You mentioned some macro databases that our members don't report to. So how are you connecting, individual efforts from a manufacturer to use electricity, use less water into this baseline that have been going on for, a generation?
I don't know if, maybe others want to talk and think about that a little bit too, with respect, who might have knowledge of these data sets. But I guess a clarifying question, you're saying that none of the facilities that you represent are subject to existing reporting requirements under either the mandatory reporting program here in California or in the federal greenhouse gas reporting program? Because that is the basis for that data, in addition to the Bureau of Economic Analysis data, which I believe, so some of these databases obviously represent broadly reporting from a number of facilities and entities across the United States. And so, while maybe the specific facilities aren't all reflected within that data, the representativeness of the data is pretty comprehensive.
I can't speak to the California mandates, but, the EPA programs that you mentioned, I don't think cover spray foam production, and there's probably a bunch of building products that aren't covered in that data. Now, the products that we buy, those companies are reporting to that piece. So you're getting the emissions of the raw materials that we use. I guess I'm missing the link from, small spray foam blending facilities to this macro data and all these data sets that you're showing, and would just like to learn more about how can we ensure that that the data you're collecting is representative of the emissions from our sector. That's what I think we're most concerned about. A lot of these, and this isn't necessarily a reflection on this because I'm not an expert in this, but a lot of the data that we see on the embodied carbon of spray foam is outdated or was never accurate. And that's something that when we think about these baseline programs, we want to make sure that the data that you're using is representative of the actual emissions from our sector. We're not denying that our products don't have emissions. I mean, every product has emissions. We get that, but we want the data to be as accurate as possible.
Yeah, so I kind of feel like your question is leading into some future decisions. So what we're doing here is we're developing this baseline to give a broad overview of both the sectoral and the industry-wide emissions for the construction and building material sector, et cetera, as it relates to buildings in California. And so, when you're saying something like, well, these facilities aren't regulated, that I assume that kind of means they're small in emissions. So it'd be great to get more information from your association of what that looks like, for one. For two, what we're doing right now, like I say, is sort of setting the stage for what we think, can be data that's useful for later efforts, like developing a strategy that will then relate to how we regulate these in the future. So I feel like maybe the core of your question is more related to what we're going to do in the future as far as how we regulate companies like that, and less so on like just the crunching the numbers of what we think the total and sectoral wide emissions are right now. Does that sound fair?
Yes, but I think my question might be a bit more fundamental. At the end of the day, while this calculation probably can't be done with currently available information, the baseline should be equivalent to the individual components of the entire building and construction sector, right? That I think that's a binary question.
Well, I think there's kind of two different frameworks here, right? We're talking about in some ways, you can think about other policies that exist at the state level. We have statewide goals, for a net zero emissions, right, by 2045. And that refers to emissions in the state. This policy is looking at the life cycle emissions, and so it's consumption weighted, right? So it's more about thinking about the entirety of the life cycle of emissions that are related to these products. And so depending on your framework, actually, the two things you said may or may not actually come out to the same number when we talk about building up from the bottom. Because are we talking about just what's the emissions released in the state, or are we talking about all emissions that are attributable to building materials that are consumed in the state? And so that's kind of a fundamentally different. I think additionally, one of the concerns you raised about, the validity or the comparability of product level production data. So your example of a specific product, spray foam insulation, and scaling that up to an industry or a sectoral wide is a challenge. And one of the reasons that we have we're advocating for the use of this method, which is a economic wide assessment, is because we have concerns about, or we have observed deficiencies within that product level data that we could use to scale that. So I think that's one of the reasons that we're putting this forward as an option, because we think that based on what's available, that these provide a more comprehensive and comparable view across the entire landscape of building materials.
So I'll ask one last question, and then I'll let others join in. So ultimately, is the goal to have end use regulations on end use products, or is the goal to reduce emissions across the building sector and let builders make decisions on how to do that? Are you going to come to a spray foam manufacturer and say you need to reduce your production emissions by 10% to help us hit our 40% goal, or is it going to be more flexible than that? Because if we're going to get to specific product regulations, hearing that you're using macro data is quite troubling to me. If you're going to make product regulations, you should be looking at our data.
Yeah,
and that exists through EPDs and other industry documents that we've already developed.
This is the question we've gotten in both of the last workshops. For one, we're guided by the statute. The statute says to reduce or to develop a strategy to reduce net GHG emissions in the building sector by 40% by 2035. And so that's the broad guidance. Specifically how we do that is through the strategy that we develop. We haven't figured out those details yet. We're still at that stage of what are the total emissions, what are the sectoral emissions. That leads to the next step, which is to develop a reporting regulation, which we're hoping to bring to the board next year. That'll get specific data, hopefully, from manufacturers of the products we've identified we will have identified in that regulation, so that we have not macro data guiding those future regulations and whether people are complying, but micro data. So, facility level data, builder level data. And so that's the reporting information that we're looking to develop. And then kind of on your, I can't remember if it was your last or your intermediate point about whether we're going to ask builders to make specific decisions or whether we're going to ask manufacturers to make specific decisions, or both, or something entirely else. That's something we will determine through our strategy development. So we're not at that stage yet of making any decisions there. It's sort of like a blank slate at this point.
Doesn't move. Hi, I'm Webley Bowles with WIP Sustainability. So I want to stay on that because I'm not hearing exactly what I want to hear. And I feel like it's an elephant in the room that I just need clarity. Like, this meeting is about baselines. I understand that. It's not about reporting. So I want to understand, how do we reduce the baseline? Like, what are the mechanisms that we can use within EIO to reduce the baseline? And it's my understanding that that needs to be economic. That's the only way to reduce that baseline. And I'm not seeing in any of these comments that people are saying that we want to reduce the economy. So what are the other mechanisms to reduce that baseline?
Yeah, so I kind of have to just address the core philosophy of the question, I guess. There's no reduction of baseline that we're talking about here. We're talking about trying to understand what the emissions of the building sector will be in 2026 through the utilization of data that is existent, and then projections to that 2026 year. So it isn't about like, how can we reduce the baseline? The baseline's just a number of what we think emissions will be in 2026. There's a whole other thing about strategy that we're going to have going forward for how we reduce emissions from the baseline to achieve our 2035 goal of the 40% net GHG emissions. So there won't be any baseline reduction. That's just not a thing. It'll be reduction from the baseline.
Can you state that again?
Okay, the baseline is a number for what exists in what we think will exist in 2026. There's no playing around with like you can't take action to reduce something that we think is a static number, right? So it's kind of like if you look back and say, can we reduce the GDP of the United States in 2022? That's kind of not no, that's a number that's static in time, and that's the intent with the baseline is to develop this number of what we think our best informed estimate of emissions in the building sector in 2026 will be.
But then the law is requiring a reduction.
Reductions from the baseline, but it's not a reduction of the baseline.
Okay, so that's the difference. So you're saying that there's going to be a different methodology to create a new baseline?
No.
No, the baseline is one number where, so like, as we go forward, we will put together a strategy for how we say, okay, in 2026, we think the total building sector emissions was X. And if we want to meet the 40% reduction, we need to have Y emission reductions. And then we go forward with our reporting reg, which is manufacturer and builder specific information. And we go forward and we say, hey, is there some regulation that we need to develop, et cetera, such that we push action to reduce the emissions in the sector, but it's not a revision of the baseline. The baseline was one static number in 2026.
So are you saying that in the future, you're not going to make that 40% reduction target based on EEIO?
So the overall 40% reduction target, let's say the baseline number for a nice round example is, let's say it's 100 million metric tons. So a 40% reduction means by 2035, the whole building sector needs to achieve a net emission reduction that would get us down to the 60 million metric ton number. How do we achieve that? Great question. We don't know yet. We're going to go through a second phase process after the reporting regulation to start identifying what those strategies are, where they come from, what components of the building sector can contribute to reductions, how can they contribute to those reductions. You know, we have existing programs in the state that might help us achieve some of those emission reductions as they are now, right? The economy decarbonizes over time. So we would anticipate there will be various things occurring. And so we're going to do a different modeling exercise that's informed by the baseline and what's included in what we're discussing today to figure out how we get to that overall, 40% reduction from that baseline estimate. And then each sector, if they have reduction targets, that is a different conversation. That will be a different portion of a rulemaking package if that's deemed to be necessary. I posted, we have the slide that was just up that kind of shows how all of that connects. And also Wes Ingerson, I think, has some insight that he can probably lend to some of this discussion that's happening. So I'll pass it over to Wes right now.
Hi, Jeff. Can you hear me?
Yeah, we can hear you.
Okay, great. Hi, Wes Ingerson. I'm a researcher at Stanford now. I was the lead of the USCIO model at EPA until earlier this year, and involved in the creation of these state models. So I wanted to answer or make a couple of technical points about the model to address a couple of the questions. The first one from the gentleman that was asking about spray foam emissions, using that example of like, hey, our spray foam maybe mixing facilities they don't report directly to these reporting entities. They're small facilities. They don't have to report. Does that mean the emissions are not counted? So let me explain. The primary source of greenhouse gas emissions now, as in the model that CARB described, is the California greenhouse gas emission inventory. So to the extent that those emissions are estimated, let's say if they're related HFC emissions or just facility-based emissions from fossil fuel combustion, if those are, to the extent those are estimated and including in like the total industrial emissions in a certain category, or they have specific, line items that are related to emissions reporting that would reflect spray foam specific emissions, then those get attributed to that industry in the modeling approach. So just to the extent like all of the emissions that are direct emissions from industries in California are attributed to their more specific NAICS sectors that exist in the model. So then to the extent those are building material sectors that are where they're purchased by the construction industry, then those wind up back in the total. So I mean, theoretically at least, that those emissions should be counted, but you have to inspect the greenhouse gas inventory to see if they're directly counted. The second point that I wanted to make is the question regarding the way that improvements can be made as measured by the model, and maybe an implication. Does it mean that we can only reduce the output or the value of the construction sector in California to reduce emissions as measured in the model? And no, that is not correct, because the greenhouse gas emissions, again, we have the estimates from all of the construction industries and all of the industries upstream that they're purchasing from. Those are related on an annual basis and updated on an annual basis, hopefully, in the California greenhouse gas inventory, then related to those sectors. So you would see, even if output was the same, but emission of those construction industries reduced, you would see a reduction in the greenhouse gas intensity of that construction sector in California. Or if their upstream emissions were reduced of their suppliers of the steel and cement, concrete, et cetera, then you would see that even if the output, the total value changes, or if the intensity declines more so than the output increases, in the case that the California construction industry continues to grow, but the intensity of greenhouse gas emissions reduces more, faster than the increase, then you would still see a decrease in the greenhouse gas emissions over time with increase in value of the sector. So I'll stop there. Just wanted to add those points.
Thanks, Wes.
Megan Thomas with DuPont. I completely understand why you're using this model instead of the EPD, like the bottom up approach. However, I think maybe a restatement of the concern might be, how do we actually measure success? Because this assumes that entire industries are going to decarbonize for the sake of California. So if we're using this measurement technique, and that doesn't happen with the whole industry, there's no opportunity for specialization, for products that are decarbonizing to come into California. So I think the fear is just, we're using this model to establish the baseline, but how are we going to show improvement if it doesn't really come out in that model?
Absolutely. I think, let me just, if this helps at all, I mean, in order to develop a reporting regulation, we needed to have a landscape analysis of what are the significant drivers of greenhouse gas emissions from the building sector. So this is giving us that landscape analysis. It's 100,000 feet, right? That is going to inform the prioritization of reporting in our reporting regulation, which will help us track progress towards any reduction targets. So reported data is how we're going to track progress towards targets. What are the strategies that individual firms might adopt, whether that be a construction firm who are making projects or a manufacturer? That is a conversation that we haven't gotten to yet, because I think it's kind of one, as Jeff mentioned, there are a number of existing statewide programs, right, which many facilities might be already subject to. And those reductions may or may not contribute to our overall 40% net reduction target. And without this first piece of the landscape and then the reported data, it's very difficult because of all the data gaps, which I think many in the room are very well aware of, it's very difficult for us to track any progress towards an eventual reduction target or even to track existing measures that firms are undertaking. You said, how do we track, how are we going to show success? Well, perhaps there's firms that are already adopting measures to reduce emissions. The reporting regulation is going to be the vehicle through which we can track those types of progress. And I think the idea with the baseline is primarily about getting a landscape for understanding where to focus efforts on reporting.
Yeah, thank you. I appreciate that. I mean, that makes sense. I think it's just the forward looking, which maybe we need to be patient here, but how do we, I'm worried you're going to have to recalculate a baseline to show success eventually, but I understand in order to identify those hotspots, you need that deep baseline data. So.
Molly from Watershed. I also used to work on a USEIO model with Wes before. Thank you for inviting me to this meeting. I want to quickly follow up on the baseline kind of question. So, Hendro, you mentioned this EIO-based kind of calculation is for setting or understanding the landscape and then set up the correct kind of mechanism for reporting. And I wonder, would that trigger a different set of baselining moving forward so that we can, I mean, as a government in California, we can ask companies to kind of report year over year so that we can track progress. So that's the first question that I have. And number two, the EIO-based calculation to determine the baseline, fundamentally, it would not absolutely equal to the reported emissions because reported emissions will be double counting, triple counting. How have you thought about addressing that problem? I have a third question, which is more on the technical side of production-based versus consumption-based, but I can come back to that later.
Yeah, so I think the question on does that create a need for additional baselining in the future? So when it comes to benchmarks for specific products or specific commodities, we do not know what that looks like yet, and the reported data is going to start informing what those benchmarks look like. We probably will need to have different methods for understanding how different industries are achieving any reduction targets that might be established in the future. And all of that is really after the reporting regulation is finished, where we're going to start talking about some of those strategies and how we might go about setting reduction targets or comparing reduction targets from data that will be reported to us. I mean, the baseline, I think, helps us understand and establish percent reductions that might be necessary to get to certain kinds of overall emission reduction goals, and then applying those percentages or looking at various other ways to map strategies onto the reported data is definitely going to be a process that we will be teeing up, hopefully in the not that distant future. And then remind me of the other questions.
The double counting and triple counting.
Yeah, great questions. I would love to jump the gun on this one, but we're going to detail information more about that on our upcoming technical meetings related to reporting, because that is definitely a reporting question on how do you track various commodities and product flows into the state and who is reporting and where do those emissions come from. Yeah, so that's hopefully in a handful of weeks here, we should get some notice out about our future technical meeting.
And I think, I see some folks in the room, so I want to just kind of get a cue going. I see Reed and Charlie and Jesse with their hands up, and I would just say that I think overall our expectation is that the baseline is a one-time exercise for the most part to get this landscape to identify the sectors and materials that we want to make sure are included in the reporting regulation, and that, as you can see on this, we've tried to illustrate in this figure, is that the intention is to have the reported data be what is used to track progress. So this is an exercise in understanding where should reporting be focused. And then the reported data will be used to track progress towards our reduction targets identified in statute. Do you want to go Reed and then Charlie?
Sure. Reed Hitchcock with the Asphalt Roofing Manufacturers Association, and maybe this is addressed down the road, but I guess where I'm a little bit confused, and like Stephen, I'm no expert in this area, but as I think I'm hearing it, the US EEIO baseline is for, in this case, the whole building sector, right? But going forward, you've got specific industries listed. So are there going to be new baselines set for each industry? And what will those be based on? Or are those industries reporting against EEIO? And in that case, I think that, for industries that have solid, EPD, LCA, PCR data, it just seems like something of a disservice not to use that data where there's actually data about that industry versus relying on sort of an amalgamation of data from across a whole bunch of different sectors when industries, again, they have the data and then they can very easily track progress against that. I think using, trying to track against what appears to be a pretty complex calculation, your series of calculations on this EEIO data, that's going to ultimately cost somebody a lot of money. And I have a concern that in the middle of, a concern around affordable housing, what have you, a lot of that's going to end up trickling down to the consumer. So I am wondering about that, the industries that have the data, can we not track against that data?
Yeah, let me make something clear. None of you all are going to have to put together a Leontief inverse matrix as part of the reporting program. That's not anything we're suggesting or talking about today. This is something we've done. You're free to look at our worksheets to see if you agree with what we've put in for the baseline, to see if you think it's reflective of the economy and the emission sources. But nobody's going to be using EEIO to report. Okay, so that I feel like that's maybe a theme that's coming across that people are confused about. People, I don't want to jump the gun on the reporting requirements and whatnot, but it's not a US EEIO reporting program. It's US EEIO is the model that serves as the numbers that help us determine what are the big industries, what's the state of the emissions across the industry. What you'll be reporting to us is going to look a lot more like data that you already collect, and the data that if you've produced an EPD that you've used to gather those up. So there's going to be a lot more detail in the reporting technical meetings, which I can tell from this meeting everyone's probably going to be a lot more interested in, which is great and fine. But today is mostly about here's the model, play with the model, see if you think there's anything wrong with the model, any ways we can improve it. So I don't know if that helps clear things up on your question. Hopefully a few questions.
Probably remains to be seen.
Okay.
I mean, you brought up the current EPD availability, which is an interesting one, right? One of the reasons that we've kind of promoted this strategy is because of the inconsistent landscape for availability of EPD data across different building materials. We've raised that a concern in our prior workshops. Obviously, there's a lot of diversity in PCR approaches as well as EPD availability across building materials, differences in accounting frameworks that are being used. This creates a comprehensive and consistent accounting framework for for greenhouse gas emissions, which is built upon regulatory data, which has the same pace of update, right? Annual updates to data compared to the PCRs, which can be 5, 7 years. Background data might be 12 years old. That's used for a valid PCR today. That pace of data, as we've raised in our prior workshop, some of the challenges with building up a comprehensive landscape analysis based on those EPDs is the comparability and lack of consistency and lack of availability of EPDs across building materials. So that's one of the reasons we promoted this strategy as a way to say, hey, we want to look across and see where should reporting be focused. This gives us a comprehensive and comparable framework to look at. And then to focus on developing carbon accounting principles, right? Greenhouse gas reporting principles that are robust and consistent and comparable across different facilities and industries and sectors in the building, contributing to the building sector. So there's got to be a little bit, we probably are trying to have a little bit of both, I think.
Thanks. Charlie Ray with the CalCEMA Trade Association for Concrete, Aggregate, Asphalt, various minerals, so all materials. And maybe you just answered this, but at this point in the baseline development, doesn't look like you're asking for companies or manufacturers to submit data or do anything of that regard. Is that?
Yeah, there's no submittal of information that we're asking from you as part of the baseline. The baseline information is already in the tool that we've developed and that we've pulled from USCEIO and all of the sources that it pulls from.
Just look like in looking at the worksheets that you're looking for someone to put input there.
Yeah, so there are a handful of assumptions staff made to, estimate and make the models as applicable to California as we could. One of those big assumptions is that the California economic landscape is pretty similar to the national economic landscape in terms of like inputs. So a facility in California tends to require the same kinds of inputs to produce, a commodity as a facility in the U.S. as a whole. That also means there's some assumptions that, may or may not be fully reflective of the California landscape compared to the national landscape, such as, quantities of limestone produced in California versus quantities of limestone produced outside of California and how that makes up the overall aggregate makeup of a specific sector. So there are things that we've simplified and assumed. We know that they're not going to be 100% accurate. And so that's really where industry partners and the public can help us improve some of the underlying assumptions in the tool. And that can help correct our estimates and numbers. I think at a overall level, probably that number maybe doesn't change a ton, but I think for individual sectors, we might see some rearrangement on, which are the larger contributions. If that makes sense.
Yeah, so to summarize, we're asking for your critique and feedback. If there are data that you think it would be important for us to know to support that critique and feedback, please do submit that. But we don't need companies to go and submit their quarterly energy information to us to develop the baseline or something like that.
Yeah, I want to let Jesse and then Matt jump in. I see Mo also was interested in jumping in.
Okay, thank you. Jesse Buckmaster with Hathaway Dinwiddie Construction. And I'm just in the interest of potential emissions that are not being accurately captured. And maybe this is getting really in the weeds in the model, but I'm thinking about, looking at the life cycle scope A4 and A5. So A4 transportation emissions. Now, if I remember, some of the data is freight analysis, so maybe that gets captured there. And then A5 is construction activities on site. So I believe construction machinery was included, but then the actual fuel spend on site. And maybe that, I know CARB themselves had that data probably, but what we're finding at a building scale in the construction industry is it is severely underreported. Most whole building LCAs are putting it about 5%, and we're finding for especially heavy excavation can be 20% of a building's life cycle for just on-site machinery, generators, that kind of thing. So does the data account for that?
I feel like honestly I should hand this question over to Mo or Ben. My short of it was I do believe it should account for a lot of that, but maybe there's a little bit more nuance that you would like to add, or Wes or Ben online. Oh, Ben has his hand raised. We can go to Ben.
Hey, thanks, Jeff. Yeah, so this is Ben Young. I'm from Eastern Research Group, and along with Mo, I've worked closely with Wes on the USEIO model and associated state models for a number of years, as well as the environmental data. So the short answer is yes, those emissions would be accounted for. And that's one of the advantages of these top-down models is we have good estimates of the total fuel being consumed across the country, and then we can attempt to attribute those fuel combustion emissions to the appropriate sector. So I don't know the nuances of exactly how California tracks their greenhouse gas emissions, but to the extent that we have data on mobile combustion emissions, we have a number of ways that we can then assign those emissions to the appropriate sectors, such as construction, machinery, and other mobile equipment of that nature.
Perhaps we can go Matt and then David.
Matt Roberts, Center for the Built Environment at UC Berkeley. Two quick things. Can I mention the project? Cool. Okay, that'll be the second part. The first part, I would just caution when you guys are moving from the baseline with EEIO to the reporting phase, that there might be a perceived reduction because it's a different method if you use a different methodology for it. So you might automatically get a 10 to 15% reduction just from switching methods because of the data availability and reporting metrics that we usually use. And then for everyone else in the room, I lead the life cycle assessment research program at the Center for the Built Environment at UC Berkeley. Part of the work we're doing right now is a project with CARB looking at cost-effective impact reduction strategies for material consumption in California. We have an advisory group panel that is setting up with some workshops starting up in September and a survey out right now. So if you're interested in sharing your voice in that, please come talk to me and we'd love to have you guys.
Yeah, that's a really great point. The first one, that as we go through and, we've developed the reporting methodology and we start to get data in and we develop a strategy that helps us to reduce the emissions toward our target, that we'll have to be cognizant that, whatever that strategy is, that we're aware of how that interplays with our reported data and we track our emission reductions according to that reported data properly. So, as many of these, it's a little unsatisfying to say, to be continued, but that's definitely in that phase. Yeah, David.
David Ware with Knopf Insulation. I echo some of the other concerns and comments that have been made by individual product manufacturers. Okay, I get the landscape. What you have said is encourage people to use this model. The model seems extremely elaborate. How is the model going to help an individual manufacturer understand where that baseline might land? I mean, how are we to use that model to our advantage? Not as a competitive thing, but as a learning tool, for example. You haven't explained how to use the model or why it's useful from setting a landscape. So there seems to be, at first glance, from what you've provided, it seems to be very complicated. So from my company's standpoint, if we start playing with that model, it's a big so what? What are we learning from that?
Yeah, so I would say that the spreadsheet that we've posted on the website, it's a bit of a cliche, but it's a bit of an onion. You can go to the dashboard, you can look at the total number, and if that's where your interest stops, you can just say, okay, that's the number that we think the total building sector in California emits. You can look at the pie chart to see how that breaks down by emissions. If those things grasp your interest and you're like, well, I want to check and see how did they get that construction was, I don't remember. Do you remember, Jeff, what the percent emissions from construction were? Something like that. Sure, a significant portion. If you want to say, well, okay, does that seem right to me? Then you can go into deeper layers and see, okay, well, what are the sectors that contribute to the construction emission? I mean, I don't know how many people will end up getting into and trying to understand all the different matrices. I don't know how many people will end up going in and selecting on and off on certain sectors to see how that affects the total emissions there. But it's like, that's the level that the Excel that we've posted sort of engages at. So if you're like, hey, I really want to go in and, you know, critique this in a deep way, you can do so. You don't have to go back to all the way to the Python scripts and everything that pull US EEIO into the Excel format. You can just do that in the Excel sheet. Maybe some of the academics here will end up checking our Python code, et cetera. So it just really depends on what level you want to interact with that. For us, the goal of the baseline is to develop to inform the regulation we develop and also the strategy that we are planning to develop in the future. And it's mandated that we do so under the statute. So hopefully that's helpful.
If I could add just a little bit, just to say, I think, you know, the first thing about the pie chart. So if you look at the spreadsheet, I would look at that and see that that is our view of what the sectoral drivers are, right? That's our idea of what we think are the most critical sectors from a GHG standpoint with respect to the building sector, right? What are the most critical pieces for building sector emissions? And so, you know, that's where I think, you know, folks in this room, and obviously, you know, the tools that we're developing have various constituencies, and obviously we're very excited, interested in hearing from our industry partners. But you know, they're aimed at, as Lex mentioned, you know, various audiences. But I think, you know, for, you know, that would be the first place to look. I would think is to look at that pie chart and to think about, okay, well, this is what CARB is going to view as the rank ordering of drivers of greenhouse gas emissions from California's building sector. How does my particular industry fit into that? Well, you can maybe look at that and see where do you think you fit in into that rank ordering. And to realize that, as we've said on that other slide with the green boxes, which I hope is helpful for folks, but is really to illustrate that from a strategic perspective, one of the priorities in developing a greenhouse gas regulation is to prioritize those sectors with the largest contribution, the low-hanging fruit to some extent, or at least the largest fruit. Perhaps that they aren't the easiest ones to decarbonize, but at least the most significant drivers. So I think that's the first place, and hopefully that at least gives folks an idea of where we are looking from a priority standpoint for developing future reporting requirements. And I think that's the main, you know, hopefully the main information to take away from.
Well, you already have identified 4 or 5 sectors. Seems to some of us that are here that those are priority sectors. And so I guess the answer is there's more to come. I think that's the answer. There's more to come. You'll see us back again.
Yeah, hopefully. Please do.
If I may add my comment to your question and maybe comment to your answer, I feel like today's session is to seek feedback, seek kind of criticism to the findings of this tool. So basically, when Andrew and Jeff and Lex talk about the pie charts, I think we want to kind of, or CARB wants to seek industry experts' feedback on, does the ranking look good to you? Does it make sense? Is there something that should be ranked in the third place instead of in the first place? That will basically be the flaws of such a model. That feedback from industry can help CARB correct a model, fine-tune a model, and then eventually use this model or the findings from this model to guide how to set up the regulation for reporting mechanism. Is that the right interpretation? Okay.
I see Matt, and then I see Webb, and then I see Megan.
I also think, just building off of your question, David, that you're talking about how you can use that model to identify within your operations how to reduce emissions. I think that might be 2 or 3 steps ahead of what that pie chart and model is intending to be used for. So if anybody is walking in and not knowing anything about GHG emissions, then they can look at that and then rank themselves relative to other industries. But if you're already at a step where you know you want to drive emissions down in your operations, you probably want to do like an organizational like life cycle assessment, hotspot analysis, and decarbonization strategy for your own operations, which that would be doing like a bottom-up assessment of your operations to identify what are the leading drivers of emissions. And then also there's the leading drivers of emissions, and then what are the easiest ones or the ones with the largest reduction potential. And then you target those ones. And then you can use that within your EPDs for your products and your corporate reporting to then drive emissions and then show your corporate due diligence in the fight against climate change.
Just a quick response. And we do that.
Yeah.
We've done that. Okay, and we continue to do that. So how is that represented, or how will that be represented? Maybe not obviously in this meeting, but in the future. Because they're doing the right thing. So you've targeted sector industries already. We want to participate. Many of us are already down the road making improvements and have set very aggressive goals for being better. So we're just trying to figure out, some of us who have done and feel strongly about the gains we've made, and future expect we'll make more gains, but how is that represented? We're not, those dots are not getting connected yet.
I feel like those dots will be connected in the reporting. So as you report year over year, your progress will be tracked.
I think one point he's trying to make, though, is that some of these companies have been decarbonizing for 10 years, and we're starting the clock now. So the ability to gain isn't looking at the whole life cycle of our industry from 1900 to today. We're looking at the last or the next 5 years, not the gains that have been made over the last 20 years. And the low-hanging fruit that you might see might not be so low-hanging on our side, because we've already chopped emissions significantly over the last 5 or 10 years. And that's not going to be captured. But again, I understand that's not the scope of today's workshop.
I mean, that's okay, because I can just really quickly answer that. And that's that the legislature of California told us that the baseline that we start from for the 40% reduction by 2035 is the year 2026. So that's just what we've been told by functionally our bosses to do. And I just wanted to mention real quick, I've seen a couple people taking pictures of the slides, which is fine, but they're all posted online, and I'm sure they're in better quality than your phone can take a picture of. So, reminder.
I think also, one of the values of this approach is a comprehensive, cohesive, and very consistent accounting framework across the industry, right? Because we do want to better understand not just the landscape, but as we move forward, and this is something we haven't, not necessarily had a lot of opportunity to discuss, is obviously we will want to make, in the legislation it talks about carbon intensity of building materials, and that's sort of a relative comparison across different categories of materials. And so there's going to be work to develop benchmarks perhaps, or other types of comparative tools, right, that we can use to think about reductions. And obviously there's going to be an uneven landscape. There's going to be folks who are, maybe more advanced and less advanced on some trajectory towards a decarbonization. And so I think one of the goals here is to start with that consistent level accounting, such that we have a good mark in time, but that we can also compare not just to individual California manufacturers, but across building materials consumed in the state, which may or may not reflect obviously certain production techniques, right? Or individual producers.
Hi everyone, Susanna with Agenda Inc. We're sustainability consultants. And so I had 2 questions, one of which you answered, so it was great actually that I got to wait for it. But it did bring up a second on this slide
And I recognize this is the feedback you're looking for offline, but could you talk through the services in retail inclusion? Is that the overhead for those stores? Is it the products that are then included in the other areas? And then I do have a follow-up second question.
Yeah. You want to dive in?
I'm happy to dive in. So, when thinking about this, so this graph is basically, if I am a construction company, this is the direct purchases I end up making as a construction firm, and then the life cycle emissions affiliated with all of those direct purchases. So if I'm a construction firm, there's various retail and other services that I use to operate. So that might be some of my employees go out and they buy sticky notes for us to utilize within our office. There are a variety of things that are included in this. It is a non-trivial task to go and back them all out to see the full subset of direct purchases that an entire construction industry makes as a whole, and what is all included. So each sector basically has some quantity of purchases from the entire economy. And so this chart with various selections will change based on what is defined as the building sector, how those purchases from the other economy stack up, and then how they end up being described and aggregated. So I know services and retail is a pretty broad aggregation. I think there's several different economic sectors independently that fit into that. And that altogether ends up making up, in this, what is that, like 8% of the emissions.
And it's not retail per se, like as a sector of retail. I mean, these includes architectural services. This includes other types of design services. This includes, retail-based consumption of building materials. So you can imagine that, you as a firm, you might purchase services, architectural services, design services, specific engineering services. Those are services and retail that included in this. And each of those services obviously have life cycle emissions associated with it because they themselves have overhead, offices, their energy consumption, et cetera, powering servers and the AI tools they're using to reply to your emails. And so, that's what's included in services and retail. And it's actually, I mean, it's non-trivial to some extent, which is kind of interesting, I think. And that's one of the takeaways from this is, and as Jesse brought up, obviously there's at a project level basis, we see often the existing body of literature shows that very little is attributable to construction emissions. But we see at an economy-wide level, actually construction emissions and transportation emissions are quite significant. And I think when this is one of the challenges with the current, life cycle assessment frameworks or life cycle assessments that have been applied to some of these materials and sectors. And I think that this, one of the strengths we see of this modeling approach is that we get a better sense of the unknown unknowns that are currently not well accounted in those.
And then the second question, so what I'm gathering from today is that this baseline is to direct the next step, and it's not necessarily going to be the one-to-one that's tracked for future, because after the first reporting year, we'll have a better picture. So with that in mind, I'm still a little confused. I think it was Leo who talked about the imports and how that's included in the current picture, because as Megan said earlier, that is going to be a big part of this because not everything is being developed in California and probably a lot of it isn't.
So I feel like there's two parts or two ways I could take that question. Are you talking about imports that are included in this baseline or imports and how they'll be dealt with as we go into the reporting reg?
In this baseline and trying to keep the blinders on that, so.
Yeah, so my understanding of, and Jeff can either take over or add, is that the USCEIO economic data includes imports into the US. And so it's an economy-wide number. And then we've got the sectoral emission factors for each sector that are then applied based on that economic number. So they're included.
Yeah, and each of those imports, it's actually a weighted average for the imports based on the regions they come from. So if you're importing cement from a bunch of different regions, those regions each have their own emission factor associated with them, and then those are weighted average to give you the import for cement emissions.
Thank you. There was a slide earlier that was talking about the import specific integration, and so I must have.
I don't know if Reed wanted to get back well, let's go Webley actually, and then maybe back to Reed.
Webley, WIP sustainability again. So I have a question about how you're accounting for A1 through 5. Is that what you're doing? Okay. So within the chart that you're looking at, how is that being captured now at this baseline stage? And how is it going to be considered in the future? Well, let's just talk about the baseline.
Yeah, so the way to kind of think of this is if I am a builder producing, a residential house, my final demand is that unit of residential housing. If I do the life cycle emissions for that purchase of that house, using the US EIO model, that gives you the complete life cycle emissions up to that time that the house is sold. So the construction of that house, so that would be A1 to A5 would effectively be covered just from including the construction sector within the USEIO model. For the B stage, those are the use stages and basically everything that happens after the purchase or the sale of that home. And so for that, we start looking at the final demand of the other sectors in the economy. So if we just wanted an A1 to A5 kind of estimate on our tool, you would just toggle basically construction sector. If you want some of those B1 to B5 series emissions, you have to start toggling some of those non-construction industries to start getting the consumption affiliated with those industries operating as part of the building sector. And so those are purchases made by non-construction entities.
And that doesn't exist now in the tool, right?
So in the tool, you can toggle it on and off. I think the default tool that we have posted does include toggles for some of those B1 to B5 sectors.
Oh, so it's not like you can toggle and see all of A1, all of A2. You've got to like know where it's buried.
Yes, I don't know if I would frame it that way because you can turn on different construction sectors, and that is kind of by how the economy is defined is going to give you A1 to A5. So you can't really isolate A1 and A2 and A3 in this. I mean, if you do a lot of additional work, you can start to estimate those, but that tool, the tool we've posted doesn't allow for that.
Work challenge, right? Because this doesn't necessarily map well to the type of life cycle stage decomposition that many of you are familiar with if you've looked at, ISO 21930 or 14,000 series, right? This is not exactly that decomposition. So essentially A1 to A3 is in the materials, right? And then the replacement, right, the B1 to B5 types of installation replacement, et cetera, is going to be within the construction sector because we hired somebody to do it. So you hired some specialty contractor to come in and replace your drywall, right? And that end consumption is going to be there. So it's a little bit of both there. And that, like I said, is a bit of a challenge, in trying to map these two types of frameworks together. But this framework does give us the ability to have a better, more cohesive, comprehensive way of looking at some of those things like A4, A5, which we mentioned as being an important driver, and as well as looking at greenhouse gas emissions across the material sectors in a more consistent way. So yes, we lose some detail, right? We have some trade-offs here in this method, and that's perhaps a criticism that could be levied, right? We do have some trade-offs in that. We lose the ability to maybe have an accurate decomposition by life cycle stage across each of these materials, but what we gain is a more consistent greenhouse gas assessment framework across the entire building sector.
If we really want to dive into the technical parts, I think there's a way to do the mapping, and then there's some kind of analysis called contribution analysis, like output contribution analysis. If we map, for example, I think the sectors begin with two ones, oil gas extraction, that could be mapped to A1 to A3, I guess. And then you kind of identify those sectors as the A1 and A3, and then if you see them in the output contribution analysis, those are your kind of attributed emissions in that. But I mean, happy to talk more about that, but
Yeah, staff have been looking at various ways to do this mapping, and I'm sure we will discuss this more in the future.
Not to gloss over it. As a general, generally that is kind of where we're at with it.
Want to do a quick time check. The agenda said that we were going to start public comments at 3:10, but we don't currently, as far as I know, have any hands raised online. So for the online participants, if you were planning to raise a public comment, if you could please use the raise hand function in Zoom so we can get an idea of whether we should continue discussion in the room, which seems quite lively, or if we need to make space for those folks online to make sure they have a space to speak as well. So bottom line there, if you're online and you want to say something, please use the raise hand function. I think we'll go to the next couple of tags up, and then we'll just monitor to see if any hands come up online.
Yeah, and additionally for folks online, you're welcome to use the Q&A feature. In fact, before we dive back, obviously I want to let people in the room speak, but we have a couple questions in Q&A. I think Jeff, maybe you can do a quick read through.
Yeah, let me read through a few of these here. So this is from Joseph Shackett. You mentioned that CARB staff have made a number of assumptions to develop the baseline model methodologies, such as the amount of limestone produced in California versus the U.S. as a whole, and you would like feedback from industry regarding those assumptions. But based on the information that you have posted, those assumptions are not clear. Would it be possible to develop a summary document about these assumptions that might enable meaningful feedback from industry? Absolutely, Joseph, thank you. We're actually going to post an Excel sheet shortly after this meeting. If it doesn't get posted tonight, it should be there tomorrow morning. And that will have kind of the core assumption that I think like industry will be very useful in kind of teasing out, which shows the weighting percentages for summary sectors. So one of the big things that we do is we decompose from summary sector industry kind of consumption patterns to a more detailed industry consumption pattern. So that's the 70 sector to 400-ish sector decomposition. And so the sheet that we're posting online has the current national percent breakdowns of how those higher resolution sectors map to the summary. And then it leaves a space for how that mapping should be for stuff produced in California versus stuff produced domestically that comes into California. And that will really help us out. So take a look at that. We can probably get it posted before 5 p.m., but definitely it should be there tomorrow morning. Another question from Ignacio Valdivia. Sorry if I butchered that. Valdivia. Because the baseline includes B stage, will CARB turn on gypsum insulation, asphalt shingles, metal windows, paint adhesives to better capture B stage embodied carbon in the statewide baseline? So the answer is I believe in the tool that we've posted, we have turned on a variety of sectors to try and capture this. If you think our list is incomplete or should not include those things, definitely add them. A lot of these kinds of B stage components do not change the overall building sector number a lot. But if you think they should be included and it's important, then absolutely let us know and weigh in on that. And then another question from Ignacio is, how will CARB disaggregate the 59 million metric tons across industries like concrete, steel, wood, and insulation? Will that split be based on IO model outputs, EPDs, or California-specific construction data? I think the answer is it depends on what the intent or goal is when it comes to the baseline side of things and starting to plan out strategy for future programs, policies, considerations, and seeing how existing programs maybe will change greenhouse gas emissions from the building sector over time. We're likely going to be using the IO model output when it comes to measuring progress towards any reduction targets in the future. Then that is likely to come more specifically from the data that we collect during reporting. So definitely tune in for the reporting technical meetings that we're going to be having in the not very distant future.
Great. A second question I saw from Jeff Bradley in the chat regarding the tool. As I said, we posted the spreadsheet already. We're going to post this second spreadsheet that's essentially a feedback form that has the assumptions in it and then has some space for feedback just to make it a little easier for folks to give us feedback. And then additionally, if interested parties who are attending today, if you have additional questions, if you'd like some other time to talk, please feel free to reach out to us and we can obviously spend some time. Happy to meet with folks more individually to discuss the tool and to help make sure that everybody understands it well enough to provide feedback. That is a goal that we understand we're bringing folks along, but we're interested in getting that feedback. I see Reed has his placard up, and then Charlie and Susanna again. Oh.
Thanks. And this goes back to the pie chart. And Jeff, you may have addressed this in response to Ignacio's question, but you've got some aggregated industries on that pie chart that I think paint a little bit of a misleading picture. So when you're combining, selfishly, when you're combining shingles and paving, what we have in common with asphalt paving is a constituent raw material. Yet you're linking those together, and I'm hoping that the answer to this question is that when we're looking at the reductions, that those are going to be considered by the individual industry sector and not lumped together. Because what I don't, the paving industry doesn't want that any more than I do. I don't know who's going to reduce faster or not, but we certainly don't want to be looking at that 8% that you're putting up there as a broader industry. It really ought to be these things really ought to be segmented out. And same, I'm looking at, gypsum is very different than concrete and what have you. Yet other industries, you're not doing the same kind of aggregation. So I would appreciate seeing those separated out.
Yeah, I mean the example of asphalt shingles and pavement. So there are specific NAICS designations for each of those sectors. So that is definitely something that, as we get into the strategy development phase, that becomes something that's pretty easy to start aggregating out and coming up with a little bit more targeted, intentional discussion on what the different strategies for those sectors might look like to contribute and what kinds of contributions one could realistically expect from these sectors over time as we get to 2035.
But as part of this process, can they be delinked now? I mean, you've got different.
So in the tool that we have, they are delinked within the pie chart. We've linked them together. So if you dig into the tool a little bit, they are, I believe they should be a little bit more delinked for you.
What I'm asking is next time you send out a pie chart, can they be on different?
Yeah, I think that's good.
Sure.
That's great feedback. Let's take that in. I think obviously we appreciate any feedback we received today, but obviously written comments as well. I think that's good feedback. Just to say that the aggregation of categories in the pie chart is somewhat designed specifically to make it more palatable to a broader audience so that you can read it because there's so many categories. That was actually most of it, is really just making it legible from the standpoint of there are 400 pieces of the pie chart and it sort of doesn't render in a text kind of way. So, but I think that's good feedback. We can definitely discuss that graphical representation. We don't want to have any confusion from that. Charlie, you want to jump in?
I think I'm still trying to figure out, what I should tell companies to do when they look at these worksheets. What is it they should be looking at or fooling around with to understand it? And then particularly, like I look at the user guide that you provided on page 3 at the bottom, it talks about the sector selection. It says reducing the number of included sectors will lower the total emissions attributed to the building sector. And I don't know. I mean, is that some action they're supposed to help with, or how do you get to that point to eliminate certain sectors or something?
Yeah, so I think that, the point of a lot of this is that there are a lot of judgment calls being made, like what is and is not part of what we should consider here for the total baseline, what is and is not part of a specific sector, et cetera. And so to the extent that there's, industry or expertise anywhere that folks have that can help inform that, and say, hey, you kind of made the wrong judgment call here, and I agree with your judgment call there. That's sort of what we're looking for. To the extent that if folks look at it and go, yeah, this is just interesting information that, I don't have anything in particular to do with that. There's nothing wrong with that either. If you want to make comments on just very broadly, these priority sectors should be changed in this way or whatever, so really any critique and feedback that folks have is going to be helpful. I'd say look at, it's great that you've started looking at the user guide. That's uh, riveting reading material, in my opinion. Look at the materials we'll post either today or tomorrow on feedback. Maybe that'll help folks as well, seeing the specifics of what feedback we have. The 6 questions that were posted in the slide deck, taking a look at those would be really helpful. Yeah, beyond that, if folks want to continue to meet with us and realize that we're not this separate as staff, we're not these 3 or 4 separate things. We're all of the programs. So if there's other parts of the Embodied Carbon program that you saw here that isn't related to today's workshop that you want to talk to us about, reach out to us. Let's meet again. So yeah.
Yeah, I want to come back to the production-based and consumption-based question. So is the current model is based on production-based assumption? Is that right? Everything is produced in California? Or
Actually Leo might have a better answer for this, but so our inventory that we use and we map onto everything, that is a production-based inventory for California. And so that we then map onto the economic flows from the state IO model with the California production emissions.
yeah, that makes sense because I mean, USCIO is like production-based model too. CETA model is also that. But I'm trying to think of in the context of guiding the reporting kind of framework and everything. I would think maybe a combination of production-based and consumption-based model would be the best tool to describe California economy as a whole, because there are companies in California who really kind of produce or manufacture cement. There are a lot of construction companies in California that buys a lot of materials from even overseas and then kind of provide the services. So I would say either production-based or consumption-based would be not accurate enough. So maybe my question is that something that CARB is considering to kind of make the model a little bit more complex, even sophisticated, to better guide the reporting framework?
If you have ideas or concepts, we'd love to definitely hear from you and chat offline a little bit about, changes or modifications or things that you think could be done to improve the accuracy and representativeness of the model. We're always trying to look to, make sure what we're informing our decisions around it maps to reality. And so if there are clear instances of things that you think could help improve that work, then we would love to hear more from you.
So I see a few questions here in the chat, or just some FAQ ones that I thought I would just pull up. A question here from Jordan Palmieri related to the energy use category currently in the baseline model, asking if it's more than A5. I believe that energy use in this case is primarily liquid fuel use by the construction sector. So this is gasoline and diesel fuels, as well as electricity use by the construction sector. It is within the context of the EIO, our baseline, our best, one of the best estimates of one of the components of A5, obviously, which is the fuel use. So I would say that A5 is a broader category of emissions generally from a life cycle standpoint than just what is listed as construction energy use, as opposed to the opposite. Additionally, I saw one here related, so there's a number of questions we've had related to existing policies and their overlap with this work. As we know, as you probably all aware, there's some embodied carbon requirements under the current building code in CalGreen for commercial structures, as well as there's the California Bike Clean Act, which covers public works or construction projects authorized by public agencies. This work is not directly connected to those programs, but we do work in collaboration with the department, with the Building Standards Commission, with the Division of the State Architect, the Housing Community Development Department, and other entities. One of the criteria that we are looking at for informing the reporting regulation is both the landscape for greenhouse gas emissions as well as coverage by existing programs. And we mentioned that in our prior workshop. So just to clarify that while the work here today is not going to directly impact perhaps in the short term any of these other programs, we are looking at those other programs for the types of sectors which are covered, with the expectation that many of those sectors probably already have a lot of expertise with respect to reporting or conducting life cycle assessments and preparations of environmental disclosures. So that is part of what we're looking at to inform prioritization and reporting. So materials in bike clean, et cetera. Hopefully that answers that question. One other one here. So just to reiterate, this is a question from an anonymous attendee. Based on the introductory statements, the quantity and quality of available EPD and PCR was not sufficient to be used for the baseline, and therefore CARB staff are recommending that EPA and other federal data be used. So to reiterate, manufacturers of building materials do not need to do anything at this time. And there's a second question here about CARB's work to promote data quality, data quality and consistency across PCRs and EPDs. So to the first question, that we are requesting feedback on our materials, but these materials are not reflecting reporting requirements for building material manufacturers. So there's no need for building material manufacturers or other industry partners to necessarily do anything actively with these tools other than understand them, hopefully, and provide any feedback. And then I think we want to talk more about the potential pathways for manufacturers of building materials to report emissions under a reporting regulation. And unfortunately, today, we're not really prepared to talk about it. As you probably are aware, it's a very methodological or a very methodical process here. Definitely the second word, methodical process here at CARB with respect to our approach to developing regulations. So we're very interested in talking more about how we think we could strengthen or promote existing reporting frameworks or build upon, leverage existing reporting frameworks for greenhouse gas reporting under this program. But we're going to look to talk about that very soon. And we're hoping to announce our next technical meeting, which we intend to hold this fall in the coming weeks. So please stay tuned on that one. Okay. Are there more questions in the room?
I was just going to make the point that we've sort of bled together a little bit the discussion and public comments. We mentioned the folks online. I think we still don't have hands up, but if there's anyone in the room who wants to make a statement that you think is better characterized as public comment versus discussion, I don't know if that distinction is important to folks, but please feel free to do so before we move to our next step slides.
Okay. Okay, I think we have a couple minutes still to maybe go through a few more of the Q&A before we go into next steps, if that's okay. Yeah, Jeff, did you have any? I see a few in here that that you had clicked on.
So we have a question from someone that would like to remain anonymous. When the legislative mandate requires a percentage of reductions from 1990 levels, how is this new quantification compared to 1990 levels when the output and values at this level of analysis aren't available from this time? So this question is kind of conflating two different statutory requirements that California has. So one is affiliated with California's overall greenhouse gas emission reductions. And so the California greenhouse gas emissions inventory and then the emission reduction programs that stem from that are baselined to a 1990 level of emissions. For embodied carbon, however, our statutory direction is to establish a baseline. And so it's a life cycle emissions baseline, not a direct emissions baseline, which is the 1990 levels baseline. So we're being asked to establish a life cycle baseline for emissions that would be in 2026. So those are two very different things. So how does this method and outcomes from the embodied carbon program impact those 1990 levels? It's not entirely clear at this time. There's obviously emission reductions that will occur at an economy level that will both impact California's direct greenhouse gas emissions, that could also reduce building sector emissions. And so there are two different kinds of inventories and different kinds of measurements of emissions that have some overlap, but it's not clear how much overlap. We also have another question, which is how is the range of GWP for a particular product sector addressed in the data used for the baseline? Do you have just a single value like an average, or do you also use lower bound or upper bound? I think there is significant value in showing the range of GWP for different product sectors in the current baseline and continuing to track that range over the years. Thanks, John O'Hagan, for that question. So the baseline approach isn't targeted to a specific facility or a specific company. It's reflective of the sector as a whole. So it's not an average emission number per se. It's the actual measured or reported emissions that end up making up California's greenhouse gas emission inventory and then US emissions inventories. So this is directly from facilities and companies that report into these programs, as well as other sources. And then it's the total of those greenhouse gas emissions, and then the total economic activity that is occurring. So it is a sector-wide. And so if you create a carbon intensity score for each of these, it would then represent the industry or sector average as a whole, but not any specific product development from a specific company, if that makes sense, and feel free to follow up in the chat.
Great. As you see a couple more comments in here. I see a number of comments related to questions about specific building materials or specific products. In particular, just thinking about inclusions of either specific materials or perhaps low carbon construction materials or supplementing cementitious materials. I think right now the analysis, just to emphasize, is at a sectoral level, right? So it's not about this model does not really look at a specific product, and so that's not included in the baseline and not really within the scope of the analysis for the baseline. But that doesn't mean that those types of materials won't be included in the scope of what we would either identify as strategies or within the reporting framework. I think, there's some questions also with respect to the categorization within the model. And I think, folks in the room raised some concerns about that categorization. There is more breakdown in the spreadsheet. You're welcome to please review the more detailed breakdown across the 400 sectors that are in the spreadsheet. But we will take that feedback into consideration on reevaluating how we're aggregating that and see if we can break down further that aggregation. But at the end of the day, part of the goal of this exercise, just to remind everyone, is that we are looking at this landscape analysis at a high level. And so, decomposing to pixels doesn't necessarily give us more information always, and that we do have a limited amount of resolution, which we think is useful from an EEIO standpoint to pursue. And I think that and maybe other folks who might work more, have a lot of experience using this type of methodology, from a methodological standpoint, EEIO is very appropriate from a sectoral standpoint to estimate emissions. But there is some challenges perhaps in using it at a product level. And so I think in this case, we're trying to focus on the appropriate use of those data. There was also some questions related to cutoff and prioritization. So I think when you look at that spreadsheet, you'll see that there is clearly some rank ordering of sectors which have larger contributions to greenhouse gas emissions. That doesn't necessarily mean that sectors that have smaller contributions wouldn't be included in the reporting regulation. It just means that as we develop the reporting regulation and implement reporting requirements, we are looking to prioritize certain sectors. And that might mean that reporting requirements could come into place over time, perhaps, or target different sectors over time. We've raised this concept in our prior workshop. We did discuss phasing in requirements. And I think that's when we look at this, we're going to look at both, as I mentioned, the inclusion in other programs. So the coverage of existing programs which require disclosures of EPDs or LCAs or perhaps project LCAs as another input onto how we strategize who should report and at what time. And the goal is to make sure that sectors that may or may not need to develop additional capacity to report have time to do so. And so, as we said, we'll talk about more of our reporting requirements in our next meetings. But as we've said in our prior workshops, I think we're looking to this information to create a longer path forward for decision making with respect to our reporting requirements. We do have a few more slides. I imagine you might talk about comments as well in your slides in public comment period. Do we have anything on? No. We will open a public comment period following this meeting. We will be welcome. We usually run a 30-day public comment period following the meeting, so folks can submit information. I have some questions in the FA here online about that. Additionally, though, this is a technical meeting, and we are looking forward to continuing the conversation. If any interested parties want to reach out, I'm sure that we would love to take some time to meet and discuss any concerns or other questions that you might have. So feel free to reach out in addition to providing any public written comments on this.
Also, the baseline worksheet, the Excel worksheet to deal with weightings of different sectors, that has been posted, so it should be available on our website.
Yeah, so you'll see them, I think. Or well, hopefully, we'll all see them.
Don't have bending.
It doesn't bend. But you don't have to be too up on it. I feel like it works.
All right. I think actually we are now in the next slide, please, Alex. There we go. Okay. So thank you everyone for participating. And we just want to cover what happens after this meeting. Staff do plan to review all feedback on the draft input-output model and the baseline methodology, and to make revisions based on your feedback. These revised models will be incorporated into the draft staff report that will be released publicly prior to the third workshop. Staff will continue to accept comments on the baseline estimate and the modeling methodology throughout this process. So we are planning to release a draft version of the reporting regulation and hold a third and final public workshop in early 2026 with a target board hearing date of May 2026. will also review manufacturer and project reporting requirements at 2 other technical meetings slated for October 2025. Please do sign up for these. Please do sign up for the Embodied Carbon mailing list for more information on registering for these meetings. This timeline envisions that reporting regulation will go into effect at the beginning of 2027. We will now end the technical meeting. Thank you, everyone, for coming and attending.
Well, we actually have a couple minutes. We're not quite at time, but I don't see any other pressing questions here in the chat. I don't know if anybody else in the room would like to raise any other concerns, questions. I know, go ahead.
Just an administrative question. Are you guys close to setting the date for the October?
Yes, we are very close. We were doing thank you for those who did respond to the survey if you're in the room. We did do some outreach to folks about getting a date. We are looking to finalize the date soon. We're hoping that it's going to be within the next month or so. I'm hoping the date will be released in a couple weeks. And that we'll email everybody. As soon as we have a date selected for those experts or stakeholders that we've already reached out to, we'll reach out to you right away and let you know that we have a date in mind. We will also be releasing, obviously, a public announcement for that meeting. But I think we will do outreach. We'll follow up with anyone we've already reached out to and let you know the date right away. And obviously, we are prioritizing those dates for which folks indicated that they are available. So if you've already provided your availability, thank you very much. We are going to make sure that we try to have an in-person meeting on those days. Anything else? Well, thank you all very much. We really look forward to continuing the conversation. I think it's going to get more exciting. We're going to have more to talk about. Obviously, this was just the baseline. Do I get a musical break? No? Okay. I often argue linear algebra is more useful than calculus. But thank you everybody for here, and we appreciate your time.